Hello and welcome to another Knife Making Tuesday. This week, lathe work. So this is Tormach's 15L Slant Pro lathe, which I've had for a few months now. Do I like it? No. I love it. I haven't been using it super much, but I've made 2 production parts on it, a few hundred of each, and I absolutely love it. So let's jump right in. In this video we're going to set up the lathe from a cold start. We're going to start up the computer and home it and do all that stuff. And then we're going to be making these little parts, which are my lock bar stabilizers for the knives. I was farming these out before, and lead times were long and quality wasn't always there, and all these excuses that now that I can make them myself, I finally have the tools to make them as good as I possibly can, which is really good. So here's a close-up of the threads. This is a 440 thread. Very short, very close to the shoulder. It's hard to do. Super thin, titanium. This thing is tiny. And then in the top part, in a secondary operation on the mill, it'll get engraved and T9 Torx put into the top. So that's secondary. And you can see this is left with a little nubby on the top. This is so that I can grab it and screw it into the next fixture. Anyway, to make these, let's start her up. So the first thing is turn the computer on. That turns the PC on. So this is currently set up as a gang tool lathe. Gang means all the tools are in a line like this, and it can quickly machine the part from one tool to the next, to the next, to the next. They also have recently come out with a tool turret, which is an automatic tool changer. It goes up here, rotates, gives you, I think it's 8 tools circularly, and then it'll switch to the next one. What's really cool is that Tormach will allow you to use the turret and a smaller gang plate, so you can have both, best of both worlds. The gang gives you faster cycle time in the end, because the part just has to go from here to here to here to here, instead of all the way up to home, rotate to the next one, and then all the way back. So it's a little bit faster. And for what I'm doing for tiny little parts, it works great. This is my bar stock here. It has to be able to, if you're using this tool, it has to be able to fit in here and not crash into the other tool. So they are pretty tight together, and you gotta be careful of that. So for longer parts or whatever, you just have to set them up a little bit differently. And that's where a tool turret is better, because you can do bigger diameter parts, you can do long parts, you can have a tail rest, tail stock, that's what it's called. I haven't used one in so many years. Okay, as I've shown before, this has a lever operated drawbar, which basically pulls closed that collet, 5C collet, and closes down on the workpiece material. Alright, the computer's been on for a while now. Next step is to take it out of e-stop, so that you can hear that starts up the machine. Hit the reset button, and then reference X and reference Z. So I'll do Z first. And you can see it's moving. The only kind of downside to this machine is that it is kind of slow in the rapid department. It's only got 60 inch per minute rapids, whereas like a big fancy industrial machine can have many, many, many hundreds of inches, if not thousands of inches of rapid. But in the end, it doesn't matter. I mean, especially with gang tools, all you're moving is from here to here to here to here, with a little bit of backward motion for home and all that, so you're not losing that much time with faster rapids. And then we'll reference X. So doing stuff like this and moving all the way back is the only time I feel limited by the slow rapids. And now if I want to move to Z, use the jog pendant, click on Z, move it over. This just feels like it takes a while. But other than that, you never feel it. Alright, so to do my lock bar stabilizers, I'm going to be using these 4 tools. These 2 are just left here from doing my spacers. One thing they really need in here is some sort of light. And maybe I can figure out some situation for that. But I have all these tools mounted upside down, And I've got a little mirror here, which just helps me see them upside down. So here's the threading tool. Here's just a CCMT turning tool, grooving tool, and grooving / parting. And then this is a what's it called? A VCMT, little 35-degree turning tool. And that's the 4 tools that I need. I don't technically need that one. I could probably do without it, but it works, whatever. And then I'm using 3/8 titanium bar stock. In a production environment, you would want to warm up the spindle and even warm up the axes, do a warm-up routine. So it could spin that at maybe 500 RPM for a few minutes, and then 1000 RPM for a few minutes, and go up and up and up. Today I'm just making one part to show you guys, because I've already made 100 of these, and there's more in the chip tray down there. So I have my quota already. I'm just doing one for this video, so I'm not going to bother about warming it up or anything like that. But I will set up how to, or tell you guys how to set it up. So I'm gonna pull the bar stock out. Collet is open. I've got my push bar here, just a big piece of steel, goes in the back, and we'll push this bar forward. Close it. Alright, now that's sticking out. Put my glasses on. Close the door. So even though the machine is homed on the home switches, it's still not perfectly accurate. You want to do one test cut on every startup so that you can reference the machine and make sure it's cutting the exact diameter that you want. So I'm going to choose the top tool, this one, which is called Tool 6. So I just simply go into the program, click that, T6, enter, and then it says right here, Tool 6 confirmed. And then move it in close. The Z measurement doesn't have to be completely super duper accurate for me right now, because it leaves stock to cut off, so the first few cuts will cut the end off anyway. That might not make sense to you, but all I really care about is the X diameter. I want that tool, if I tell it to cut 3/8 of an inch, I want that to measure exactly 3/8 of an inch. So I'm going to do a test cut right now. You can see it's really close. And that tool is currently at 374. The bar is 375. So that should do a 1/2 thou cut. Maybe I'll do it a little bit more. I'll do a 5 thou cut. There. So that should do a 5 thou cut. Close the thing, turn the spindle on. From a fresh restart, I got a tight bend 1000 RPM. So I got 1000 right there. Spindle on. Now I'm just going to move it over. Now from here, I can either turn the spindle off, move the tool back and then over, and then back to exactly where I had it, which is probably the best way to do it. So spindle off. It's at 3.37. So I'm going to move it up, over, and then down again to 3.7. Move it out of the way. There you are. So this is my Char's digital micrometer that measures in half-tenth increments. That's a lot of zeros right there. As I said in my last lathe video, this tool is only about $45, which is a fantastic value. If you're really precision, you'd get the fancier brand name ones that are more like $150 or more. But for me, this is fine for now. So I'm going to use this. I'm going to measure the diameter of that. Wow, look at that. .3701 or 37005, depending on how I'm holding it. Wow. Or if I pull it even out. So essentially that is reading exactly bang on from a cold start. That's the first time I've had that happen. Usually it's about half a thou off, like 5/10, which is not a huge tolerance, but you know, perfection being all that it is, I like to make it perfect. So that's fantastic. That means the limit switches are completely accurate this round. But same story goes if you crash the machine or if you hit reset or e-stop or something like that, it's best to do a test cut, measure, and verify your diameter. And now that I've verified this diameter, I know that from my previous offsetting jobs that all of these tools will cut the same diameter that they're supposed to. And for that matter, that is how I would set the diameter of that tool. So if I just put this tool in here, if this was the first time I put that tool in, I would do a test cut exactly like that. I'd move it out back to where it's supposed to be. So it says it's a 370, and I would go into the offsets page, type in tool 6. I would type in the measured diameter, which in this case is 370, but let's say it measured .3707 or something like that. Then I would hit enter and then touch X, and that would now set the diameter for that tool and the offset to where it's supposed to be. But it measured perfect, so I don't have to do that. Now for this part, I know that I want the stick out of the part to be an exact certain amount. So I'm going to loosen the drawbar so it's loose. And I like to bang it up against this tool so that I know exactly to set the stock length, it pulls out to that tool. And then for this instance, I'm going to use that tool to push it in. There, so I just pushed it into the exact right amount, which for me is .0125. Now I'm going to close it, and then we're ready to rock. This part is ready to machine. So normally I would run flood coolant on this, or it's not really flood, it's more like just a trickle. But for filming purposes I'm going to keep the coolant off, and hopefully it doesn't burn off my tools or anything like that. It should be fine. If it does crash, at least we'll have it on video. Alrighty. So the first thing is it goes to the home position. So of course I said I'm going to have the coolant off, but I left it on and water all over the lens. Can you get the air hose? Oops, I left the coolant on. Let's try this again. So it moves to the home position first. I realize now that this operation could be done a lot faster if I used this tool. If I use that tool to groove that, instead of making this turning tool do all these light cuts. It could be done a lot faster with the other tool. But this works fine. Back to home. Here it goes to that 35-degree tool. Notice it puts a little relief on the base of the threads. Threading. Now it's going to finish that profile once again, just to clean up any burrs. Not super duper necessary, but makes it nice. Apart. Notice how it's backing off, it's putting a chamfer on that one corner. Parting off, and then I'm going to retract because I want a big nub on there so I can grab it with the drill for the next operation. And then I slow down right at the very end. Look how close that got. That's cool. It's fun watching it on camera super close. I can't see that close while it's running. But you can see how close some of these tools are getting to the collet. You obviously have to watch that, be super careful, but if it clears, it clears. You know? So now it's left an exact gap there. So if I loosen the drawbar and put my little steel bar in, I'm trapped behind the camera right now. There. Tighten the drawbar. That was fun. Let's do another one from a different angle. Okay, so that run takes 2 minutes and 36 seconds. As I mentioned, there are ways to speed it up and make it faster. I could probably get it down to like 1.5 minutes if I was really pressed for time. But at the moment, it works incredibly well the way it is, and it's only 2.5 minutes, and no big deal. So let's run another one. So that is how this Tormach lathe works. I absolutely love it. As I said, the only kind of minor things are the rapids are slow, but so what? And the lever-operated collet closer is good for low-volume stuff, but when I want to make 100 of these, and it's only a 2-minute run, or 2.5 minute, and my spacers that I make are only a 1.5 minute run, we can't do anything else while this is running because, 2.5 minutes, I got to come in here, boom, 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 and it's a distraction from my other work. So the next phase for me is to automate this, and there's a couple ways to do that. Tormach's got a kit that they're developing to make this pneumatically operated, so a little air cylinder will pop it. So I'm going to try to buy one of the first ones of those that they have, or if that's going to take too long, I'll just make my own. So once you can loosen this automatically, then you can get a bar puller which kind of takes the end of the workpiece and grips it and grabs it, pulls it forward, and then the collet closes, and then the gripper lets go and pulls back. So those two things are my next upgrades for this machine, and that will let me do unattended operations. So I can program, run this code 100 times, or I can measure my workpiece, and if this is 36 inches long and each piece is only 1/4 inch, including the cut, then you can calculate how many are in here, plus a little bit to grab onto at the end. And you can say, okay, there's 94 in here. So program it to run 94 times. And then when the machine stops moving, you know it's done. as long as your tools don't break. And if they do, then you're kind of screwed. But lathe tools seem to last for quite a long time. Certainly the length of a bar, so it's good stuff. Yeah, so once I automate it, I can make all kinds of cool stuff like screws and pivots and all kinds of stuff. Alright, so that'll wrap up this video. Hopefully we got lots more lathe videos coming up in the future. Maybe I'll come up with some random projects just for the heck of it. So I can show you guys the whole process of kind of designing something new and how I would write the code for it. And then make it and use it. So stay tuned for that. Thank you very much. Goodbye.